Hello everybody. It's time for a riveting journey into the world of science. Today, we are going to explore a relatively new method of waste management and electricity generation, and it's called plasma gasification. While the name sounds daunting, the process can be described quite simply. Plasma gasification is using plasma to vaporize solid waste and turn it into syngas, a gas that can be refined into a usable fuel, which can be sold or used for energy, or could be used to power a hydrogen economy. This means plasma gasification can become a viable replacement as a source of fuel. Plasma gasification is also a viable method of removing solid wastes, and the wastes used in plasma gasification are reduced to 1/150th of its original amount. As such, the technology addresses the global issues of waste management and clean energy production. So how exactly does it work? Let's take a look.
According to Byun, plasma gasification occurs under 3 steps. First, the pyrolysis of gaseous, liquid, and solid waste without presence of oxygen gas. These same wastes then undergo the second step, gasification, which in an oxygen-deprived system produces the actual syngas. Syngas being a mixture of carbon monoxide and hydrogen gas. Finally, the remaining waste as well as the syngas undergo the third and final step, vitrification. Vitrification separates the remaining waste from the newly formed syngas and plays a role in the management of the waste that were initially used in the plasma gasification reaction. The solid waste formed after vitrification is called slag, which is either stored or used as construction material. The latter of these two options being the more environmentally friendly and as a result the one to be opted for. Of these 3 steps, the most important are the first 2, because in the first 2, the new fuel source is actually formed, while the third is mostly the removal of the waste remnants. In both the first and second step, the system is oxygen deprived. By depriving the system of oxygen within the first pyrolysis step, it becomes assured that nothing is completely burnt to ash, but instead, the solid waste is turned into char and tar. In the second gasification step, the char and tar are turned into the actual syngas that is used as fuel. This second step is also when plasma becomes involved, and is a main component in actually forming the syngas. For those who don't know, plasma is a high-energy form of matter, found in plasma televisions, fluorescent light bulbs, and lightning. Plasma is when matter has ions and electrons floating in the same gas. In this case, this stimulates chemical reactions and donates electrons to those reactions. The syngas formed after gasification is merely hydrogen gas and carbon monoxide. To refine this product to produce even more usable gas, the system goes through a water-shift gas equilibrium to turn carbon monoxide and water into even more hydrogen gas and carbon dioxide.
So, why would you choose to use this technology? Because it's a very environmentally friendly form of waste management, fuel creation, and energy generation. Plasma gasification keeps waste from ending up deposited in landfills or dumped into the environment. It is also much cleaner than the current most common waste elimination and energy generation method, which is incineration. Incineration of fuel and waste requires an excess of oxygen, and fuel incineration uses up fossil fuels, which are a limited resource. In addition, the incineration process results in large amounts of greenhouse gases, particularly carbon dioxide, to be released into the air, as well as nitrogen oxides and sulfur oxides. In addition, 30% of the burned material is left over as ash, which is hazardous to the environment. Gasification, however, has many advantages over this incineration process. Gasification requires a limited amount of oxygen input, and instead of the harmful CO2 produced by incineration, this produces more CO and H2, which are then converted into a syngas. This syngas can then be turned into clean fuels such as ethanol. In some plants, this created fuel can be sent off to be used as fuel elsewhere, and in others it is combusted there at the plant in order to generate energy in a cleaner way than by burning fossil fuels. The gasification also eliminates the generation of the dangerous nitrogen oxides and sulfur oxides. In addition, as opposed to the hazardous ash and waste components produced through incineration, the waste in gasification is reduced to approximately 1/150th of the input material, and this product is a non-hazardous slag that can be easily applied to many fields, such as being used as construction material. As it eliminates the need of fossil fuels, provides a safe means of eliminating waste, and generates cleaner fuels which can be used to generate energy. The plasma gasification process is a much more environmentally safe means of waste management and energy production.
Let's take a look at the costs and profits of a plasma gasification plant. It is found that the initial cost of starting a plant would be around $130 million. Today, there is a plasma gasification plant that works on producing electric energy instead of fuel in Iowa. According to their data, they feed in about 724 tons of waste per day, and from that waste, they create enough energy to make around $16 million per year, selling the electricity at about 6.5 cents per kilowatt hour, and providing around 2.5 times 10 to the 8th kilowatt hours per year. Though this is different in the sense that this plasma gasification plant produces energy instead of fuel, it does prove that a plasma gasification plant is a viable option for the future, if not for fuel, then at least for electricity.
While it may seem like plasma gasification is a good replacement to burning waste to reduce the size of landfills and be a great new fuel source, it is important to note that there are a few problems with this innovation. First, plants may not be able to consistently provide enough energy to suit demand. At the moment, there are very few plasma gasification plants that can provide the same amount of energy as normal power plants, and of those plasma gasification plants, all undergo maintenance for months at a time. This means for a few months during the year, the plant is shut down and not making any power while the energy need is still there. Also, due to how new plasma gasification is, and its nature of processing waste through high energy reactions, plants are very expensive to build. This means a high initial cost. Lastly, because of how new this process is, it is a high risk financially and technically. Governments using this system don't know if a plant can be built well enough to stay operational for an acceptable portion of time. To sum things up, plasma gasification is an interesting and promising technology that deserves to be researched more and should be a candidate for communities dealing with problems of waste management and energy.